Hello students. In this lecture we start transition metal organometallic compounds. A large number of organometallic compounds are based on transition metals. Examples include organic derivatives of iron, nickel, chromium, platinum and rhodium. Many important industrial processes are catalyzed by transition metals or their complexes. A transition metal complex consists of a transition metal atom or ion bearing attached groups called ligands. Essentially, anything attached to a metal is a ligand. A ligand can be an element O2, N2, a compound NO, or an ion CN. It can be inorganic, as in the examples just cited, or it can be an organic ligand. Ligands differ in the number of electrons that they share with the transition metal to which they are attached. Carbon monoxide is a frequently encountered ligand in transition metal complexes and contributes 2 electrons. It is the best thought of in terms of the Lewis structure, in which carbon is the reactive site. An example of a carbonyl complex of a transition metal is nickel carbonyl, a very toxic substance which was first prepared over 100 years ago and is an intermediate in the purification of nickel. It forms spontaneously when carbon monoxide is passed over elemental nickel. Many transition metal complexes include nickel carbonyl obey what is called the 18 electron rule. You know about the 18 electron rule, which is to transition metal complexes as the octet rule is to main group elements. It states that for transition metal complexes, the number of ligands that can be attached to a metal will be such that the sum of the electron brought by the ligands plus the valency electrons of the metal equal 18. With an atomic number of 28, nickel has the electron configuration 4s2 3d8, that's mean 10 valence electrons. The 18 electron rule is satisfied by adding to these 10 the 8 electrons from 4 carbon monoxide ligands. A useful point to remember about the 18 electron rule when we discuss some reactions of transition metal complexes is that if the number is less than 18, the metal is considered coordinatively unsaturated and can accept additional ligands. Not all ligands use just 2 electrons to bond to transition metals. Chromium has the electron configuration 4s2 3d4, 6 valence electron, and need 12 more to satisfy the 18 electron rule. In the compound benzene tricarbonyl chromium, 6 of these 12 are the sigma electron of the benzene ring, and remaining 6 are from the 3 carbonyl ligand. This is a structure of iron metal organometallic compound named ferrocene. It has an even more interesting structure. A central iron is pi bonded to 2 cyclopentadienyl ligands in what is aptly described sandwich. It too obeys the 18 electron rule. Each cyclopentadienyl ligand contributes 5 electrons for a total of 10, and iron with an electron configuration of 4s2 3d6 contributes 8. Alternatively, ferrocene can be viewed as being derived from Fe2 plus and 2 aromatic cyclopentadienyl rings. Indeed, ferrocene was first prepared by adding iron second chloride to cyclopentadienyl sodium Instead of the expected sigma bonded species shown in the equation, ferrocene was formed. After ferrocene, a large number of related molecules have been prepared, even some in which uranium is the metal. There is now an entire subset of transition metal organometallic complexes known as metallocenes, based on cyclopentadienide ligands. These compounds are not only structurally interesting, but many of them have useful applications as catalysts for industrial processes. Naturally occurring compounds with carbon metal bonds are very rare. The best example of such an organometallic compound is coenzyme B12, which has a carbon cobalt sigma bond. Pernicious anemia results from a coenzyme B12 deficiency and can be treated by adding sources of cobalt to the diet. One source of cobalt is vitamin B12, a compound structurally related to but not identical with coenzyme B12. To be continued in next lecture. Thanks.